Following the demise of the dinosaurs at the end of the Cretaceous, mammals and birds began to radiate into diverse forms on land, underwater, and in the sky. Early in the Paleogene, fish and reptiles had taken on more recognizable forms and did not change very much. At the start of the Paleocene epoch, 65 million years ago, mammals were small and insectivorous, with little limb or teeth specialization. They soon began to change in order to exploit the ecological niches left vacant by the dinosaurs growing in size, evolving new modes of locomotion, and diversifying their diets to include plants and other vertebrates. The mammalian radiation continued during the Oligocene. Bats are sparsely represented in the fossil record because their light bones and delicate wing membranes do not fossilize well. For this reason, the precise time in evolutionary history that bats took to the air is not known. However, a few excellent bat fossils that have been found at two locations dating from the Eocene epoch, an oil shale pit in Germany and the Green River Formation in Wyoming, show that flying bats existed at least 52.5 million years ago. Their arm and greatly elongated finger bones support a stretchy skin membrane that, powered by muscles, enables flapping flight. Bats probably evolved from a nocturnal insectivore that glided from tree to tree. The first fruit-eating bats did not appear until the Oligocene fossil record. At the beginning of the Paleogene, mammals had unspecialized teeth that could cope easily with their diet of insects. During the Paleocene epoch, however, two major groups of mammals, the carnivores and the creodonts, evolved teeth suited to a diet of meat. Carnassial teeth, the defining feature of modern-day carnivores, are supremely adapted to shearing flesh from bone in a scissor-like action, while the large, pointed canines deliver the killing bite. Carnivore ancestors, the myiacids, were small, weasel-sized mammals. Dogs appeared during the Middle Eocene and true cats in the early Oligocene, in parallel with a cat-like group called nimravids, also known as false saber-tooths. Nidea is thought to have been a freshwater relative of the modern herring. Every year, huge numbers of Nidea fossils are unearthed at quarries in the Green River region, and they are a common sight in rock shops around the world. Most Nidea specimens are small, but very well preserved. The sheer number of specimens suggests that Nidea lived in large schools in the Green River. Nidea's body size and abundance tells us that the fish was probably a secondary feeder, filtering out ostracods, diatoms, and other microscopic plankton in the lake water. Many Nidea skeletons have been found in the stomachs of larger fish. This squirrel-sized primate, nicknamed Ida, is remarkable for being the most complete primate fossil ever found. Even its final meal of leaves and fruit is preserved in its stomach. Darwinius's skeleton shows it to have been an agile but generalized climber, and some scientists think that this animal, while still technically a prosimian, is close to the origins of anthropoid primates, and thus a distant ancestor to humans.
Uintatherium was a giant horned mammal from the Middle Eocene. Most of its fossils have been found in Utah and Wyoming, but it was widespread across North America and Asia, although probably in small numbers. It had huge upper canine tusks that protruded downward and were protected by a bony flange on the lower jaw. The snout had a series of blunt, horn-like growths. Like modern rhinoceroses, both sexes had horns. As is true of horned mammals today, they probably used their horns for display and species recognition. Large upper canines are also used in display of some small deer today. Uintatherium has no living descendants, and where it fits in the family tree of hoofed animals is a controversial subject.
An ancestor of modern whales, Ambulocetus retained strong legs and could walk as well as swim. It may have hunted like crocodiles, lurking in the shallows and then lunging forwards onto land to catch prey that wandered near the water. We know Ambulocetus was a relative of modern whales because of the shape of its skull and teeth. The similarity of its jaw and middle ear to that of modern whales suggests that, like them, it was specialized for underwater hearing and might have lacked the external ear that picks up sounds on land. Ambulocetus is one of many transitional fossils that show how whales evolved from land mammals. Diatryma was a huge, flightless, hunting bird. It is known from complete skeletons found in early and Middle Eocene rocks in the western United States that formed from a densely forested landscape. A very similar bird, Gastornis, lived in the forests of Europe at around the same time. Large Diatryma specimens are more than 61/2 of a foot, 2 meters, tall and have a huge skull bearing a robust beak with a hooked tip. Diatryma also had stout legs with massive clawed feet, but the wings were tiny and vestigial because the bird was too heavy to fly. Diatryma was an active hunter, and its powerful hooked beak was ideal for ripping flesh and crushing small bones. It has been calculated that the beak was strong enough to crack open a coconut, and Diatryma probably supplemented its diet by scavenging dead bodies and foraging for fruits and other plant foods. Diatryma was well suited to feeding in the Eocene forests, making use of their high-density food supplies. However, as the global climate warmed, the forests turned to open plains. Despite its immensely powerful bite, Diatryma was no match for the speed and agility of the mammalian carnivores that evolved to hunt on the plains.
Andrewsarchus was a giant predator that lived between about 40 and 37 million years ago. Most of what we know about this mammal comes from a single skull found in Mongolia. The skull is huge, more than 3 feet 3 inches, 1 meter long, and it is estimated that the animal's total body length was about 124 feet, 3.7 meters, with a weight of about 550 pounds, 250 kilograms. That makes Andrewsarchus the largest predatory land mammal that has ever lived. Andrewsarchus's pointed teeth are often worn and blunt. This suggests that it not only hunted large prey but was also a scavenger. Its enormous jaws would have crushed the bones of animal carcasses.
Following the sudden demise of the dinosaurs, the snake Titanoboa was the largest land hunter in the Paleocene. It was also the largest snake ever known, being 30% larger than today's longest species. Its back would have been 3 feet 3 inches, 1 meter, off the ground. Titanoboa's enormous vertebrae were found in coal deposits in Colombia, along with the remains of the crocodiles and turtles preyed upon by the giant snake.
This species was a dog-like predatory mammal that lived across the northern hemisphere in the Oligocene and persisted into the early Miocene in Africa, finally dying out there 15 million years ago.